Imagine a world where your clothes could do more than just cover your body. A world where they could act as your very own personal assistant. Sounds futuristic, right? But how far are we from this reality? Let's take a moment to dive into the world of wearable technology, a realm where science fiction meets reality. Its history traces back to the humble calculator watch and the first portable computers. Fast forward to today, and we're surrounded by smartwatches, fitness trackers, and even smart glasses. But that's not where the story ends. The horizon of wearable tech is expanding, and the next big thing? Textile actuators, or as they're more thrillingly known, wearable artificial muscles. Just imagine your clothes helping you lift heavy objects or improving your athletic performance. The future of wearable technology is unfolding before our very eyes, and it's more exciting than we could ever have imagined. To understand how we might arrive at this future, we need to delve into the development of textile actuators, the core technology that could make these smart clothes possible. The initial development of textile actuators was a journey filled with challenges and breakthroughs. The primary requirement was to create a technology that could mimic the flexibility of human muscles while being as lightweight as possible. This meant looking beyond traditional rigid materials used in robotics and exploring more flexible, soft materials. The early stages were fraught with hurdles. The main challenge was finding a material that could handle the necessary strain and stress without breaking. The material needed to be both flexible and strong, a combination not easily found. The answer, it turned out, lay in textiles. Textiles, by their very nature, are flexible and can be woven into complex patterns to enhance their strength. The idea was to combine the strength of textiles with the power of actuators, devices that convert energy into motion. This was no small task. It required the integration of technology and textile in a way that had never been done before. The first successful textile actuator was a game changer. It was constructed from conductive yarns and powered by electric currents. The result was a lightweight, flexible actuator that could be incorporated into clothing. This was not just a scientific achievement, it was a gateway to a world of possibilities. Imagine a shirt that could help you lift heavy objects or a pair of pants that could help you run faster. The implications were, and still are, enormous. The birth of textile actuators meant that wearable technology could be more than just smartwatches and fitness trackers. It could be clothing that enhanced our physical abilities. The success of the first textile actuator spurred further research and development. Scientists and engineers began exploring other materials and techniques to build more efficient, more powerful textile actuators. The birth of textile actuators marked a significant step forward in the evolution of wearable technology. This was not just about creating smart clothing, it was about pushing the boundaries of what technology could do and redefining our relationship with the clothes we wear. As with any technology, textile actuators didn't just stop evolving after their inception. As we delve into the fascinating world of textile actuators, we find that, like any other technology, they have been on a constant journey of evolution. The development of textile actuators has been an exciting process of exploration and innovation, pushing the boundaries of what we thought possible. In the early stages of their development, textile actuators were made of simple materials, which offered limited functionality. But over time, as the field of material science advanced, the materials used to construct these actuators became more sophisticated. Today, we see a wide range of materials being used, including conductive threads, shape memory alloys, and even advanced polymers. These materials not only offer more functionality but also provide greater durability and flexibility, making them more suited for wearable technology. But it's not just about the materials. The design and construction of the actuators have also seen significant advancements. One of the most notable developments in this area is the use of stretchable patterns to amplify strain. By designing the actuators in specific patterns, we can make them stretch and contract more, thereby increasing their movement and force. For example, imagine a textile actuator designed in a zigzag pattern. As it stretches, the zigzag pattern allows for more movement than a straight line, amplifying the strain and increasing the actuator's force. This evolution of materials and design has had a profound impact on the capabilities of textile actuators. Today they can mimic the complex movements of human muscles, making them ideal for use in wearable technology. They can be used in smart clothing that can adapt to the wearer's body movements, in prosthetic limbs that can move more naturally, and even in exoskeletons that can enhance human strength. The evolution of textile actuators has opened up a world of possibilities for wearable technology. Each advancement brings us one step closer to a future where wearable artificial muscles are not just a concept, but a reality. And that's just the beginning. As we continue to innovate and push the boundaries of what's possible, who knows what the future holds for textile actuators and wearable technology. Now that we understand the science behind textile actuators, let's look at how they're being used today. Wearable artificial muscles are not just a fascinating concept, they're a reality transforming various sectors. In the healthcare industry, for example, they're assisting patients with mobility issues, helping them regain independence and improving their quality of life. In the world of sports, they're enhancing athletes' performance, giving them the extra push to break records. They're even making strides in the fashion industry, creating clothing that adapts to changes in body temperature or movement, offering comfort like never before. There's also a great deal of interest in their potential use in space exploration. With the ability to amplify human strength, they could help astronauts perform physically demanding tasks in challenging environments. These applications are just the beginning. The potential uses for wearable artificial muscles are limited only by our imagination. So, what does the future hold for wearable technology and textile actuators? As we gaze into the crystal ball of technological advancements, we see a world where wearable artificial muscles aren't just a novelty, but a necessity. Imagine a future where our clothes help us lift heavy objects, or where the elderly regain mobility with the aid of smart textiles. The transformative potential of wearable tech is limitless. We're looking at a world where textile actuators could play a vital role in rehabilitation, augmenting human strength, or even in the world of fashion, creating dynamic, responsive clothing. Material science will continue to evolve, leading to lighter, stronger, and more efficient textile actuators. And as we perfect stretchable patterns, we'll see an amplification in strain, making these wearable muscles even more powerful. The future is wearable. Are you ready to embrace it? Don't forget to subscribe, like, and share to stay updated on the future of wearable technology.